Hello students, welcome to my academy, the place for mathematics and science. Dear students, let's continue the chapter Force and Laws of Motion. And remember, this is fifth period of this chapter. In fourth period, we learned two important laws of motion. One is law of momentum as well as law of action-reaction. We had got the detailed information about these two. In today's class, we are going to focus on another important concept, and this concept is related to momentum. Please do remember, once you just recall the definition of momentum, or else first meaning of momentum is the impact produced by a moving body, and its definition is the product of mass and velocity of a body is called momentum, and formula P is equal to m into V, and its SI unit, it is kilogram meter per second. Just know this one. And before going to learn the concept related to momentum, once we shall recall an important concept called energy, which we have already discussed in our previous classes, right? Then how do you define energy? Yes, it is the capacity of a body, nothing but the capability of doing work. The capacity to do work is called energy, and energy is denoted by the symbol E, right? And what about its SI unit? Its SI unit is joule, and symbolic representation is capital J. Dear students, we have different forms of energy. Can you recall them? Different forms of energy. Energy produced by the sun. It may be, it produces the heat radiations, heat energy, then light energy, then other than that, some other forms of energy like electrical energy, sound energy, atomic energy, chemical energy, mechanical energy. These are the different forms of energy. And even we have learned that how the energy is converted from one form to another form, and what devices will be used for these conversions, right? We have learned about these in our previous classes as well. Let me take a simple example. Could you tell the energy conversions takes place in battery or a dry cell? Yes, it is chemical energy into electrical energy. If it is solar cell, that is, it converts light energy into electrical energy. Dynamo, mechanical energy into electrical energy. And the motor, what we use in the electric fan. Yes, what is the energy conversion? Here, electrical energy is converted into mechanical energy, right? See, during the conversion of energy from one form to another form, will there be any wastage of energy? Not at all. Example, you may assume the running fan. So, running electric fan. When you switch up, the fan will start rotating. It starts running. Here, could you tell the energy conversion? Electrical energy is converted into mechanical energy. We have used electrical energy, but it is not wasted. This energy is used for running the fan. So, here totally energy is conserved. Then what do you call that? It is called law of conservation of energy, right? Here I'll go for writing. Law of conservation of energy. Then what is the statement? According to this, energy can neither be created nor destroyed, but it can be converted from one form to other. Okay? Actually, this concept has not been given in the textbook, but it is needed for learning the further concept. In today's class, we are going to learn an important concept that is called law of conservation of momentum. What it is? Law of conservation of momentum. Yes, I'll go for writing that, and before that, even I'll write the information about this also, energy. Dear students, now let us learn about law of conservation of momentum. Just once you recall the meaning of momentum. What is that? It is the impact or effect produced by a moving object. If it is moving object, it will be having some velocity, right? I am going to consider two objects which are moving with different velocities. I call them as u1 and u2. Here, I'll show that. Look here. This is a straight path. On this path, we have two objects. You may call these objects as A and B having different masses. Object A has mass m1 kg, object B has mass m2 kg. And both are moving with some velocity. The velocity with which A is moving, you may call it as u1, and the velocity with which B is moving, it is u2. Assume that u1 is greater than u2. Hope that you have understood. Both objects are moving along a straight line in the same direction. When the initial velocity of the object A is more than that of the B, so after some time they collide each other, right? Here also, this is A and this is B. Then here, when A collides with B, then what happens? A will exert some amount of force, and at the same time even B will also exert force on A. Can be shown like this. Clear? So when they collide with each other, will there be any change in their velocities? Certainly. They start moving with different velocities. Here are right. This is the object A moving with the velocity, call it as V1. And object B, it starts moving with the velocity V2. Clear? Here we have three situations where in one of the situations the objects will collide each other. But it is before collision happened, and this is after collision happened. So we can write the situation as, here I'll write, it is before collision, and this is during collision, and what about this situation? It is after collision. Okay, here according to the statement, law of conservation of momentum. So total momentum should be conserved. That means the momentum of two objects before collision must be equal to momentum of two bodies after collision. So we do not know their momentum. Let us go for that. Here I'll write before collision. This situation will be taken. Here, what is the momentum of A? This is initial momentum. Initial momentum of A. This is m1 u1. Clear? Then what about initial momentum of B? This is m2 u2. After some time they collide with each other because u1 is greater than u2. Here I'll write u1 is greater than u2. Therefore, we can take the situation after collision. Here I'll write. Then their momentum will be changed. I'll write final momentum of A. It is m1 v1. There will be no change in the mass. Then final momentum of B. What it is? It is m2 v2. Clear? Okay. Then I'll go for taking the rate of change of momentum of A. Here I'll write rate of change of momentum of A. How do you write this? Rate of change of momentum. See that its initial momentum is m1 u1, final momentum is m1 v1. Hence it can be written as m1 v1 minus m1 u1 divided by t. Clear? Yes. This can be written as rate of change of momentum. It is nothing but the force. It is the force exerted by A on B, FAB. This is equal to m1 v minus v1 and m1 u1 divided by t. In the same way, we can also find out the rate of change of momentum of B. Here I'll write rate of change of momentum of B can be written as it is m2 v2 minus m2 u2, right? Final momentum of B m2 v2, final initial momentum of B m2 u2 divided by t. Rate of change of momentum of a body is directly proportional to the applied unbalanced force. So that we can write it is the force exerted by B on A. It is equal to m2 v2 minus m2 u2 divided by t. Clear? Now, according to Newton's third law of motion, we know that to every action there is an equal and opposite reaction. Action is the force exerted by A on B, that is FAB, which is equal to the force exerted by B on A, but it will be in opposite direction. Then, what is FAB? It is m1 v1 minus m1 u1 divided by t. This is equal to minus of. It is m2 v2 minus m2 u2 divided by t. See the t and t get cancelled. This is m1 v1 minus m1 u1 is equal to, multiply minus with both the terms. This will be minus m2 v2, then minus into minus plus m2 u2. Clear? This can also be written as m1 v1. Transfer v terms, take right u term and v terms separate. Here v term is there, minus m2 v2 becomes plus m2 v2. This is equal to m2 u2 plus m1 u1. Hope that you have understood. I'll go for interchanging the terms. See that m1 u1 plus m2 u2. It is equal to m1 v1 plus m2 v2. Just observe here. What does m1 u1 indicates? It is the initial momentum of object A. m2 u2, it is initial momentum of object B. m1 u1 plus m2 u2, it is the sum of momenta of two bodies A and B, right? It is before collision. Then m1 v1, it is final momentum of A. m2 v2, final momentum of B. m1 v1 plus m2 v2, it is the sum of momenta of two bodies A and B after collision. See that? The sum of momenta is the plural of momentum. The sum of momenta of two bodies before collision is equal to the sum of momenta of two bodies after collision. Clear? That is the statement. Now I am going to write the statement. Dear students, here I have written the statement of law of conservation of momentum. See that the sum of momenta of two bodies before collision is equal to the sum of momenta of two bodies after collision, provided there is no external unbalanced force acting on them. Here, no external unbalanced forces are acting, just two objects are moving in a straight line with a different velocity. Then, due to u1 is greater than u2, then both will collide with each other. After that, they start moving with a different speed, hence their momentum will also be changed. But momentum of two bodies before collision will be equal to momentum of two bodies after collision. So, in the examination, they may ask you the question like this: state law of conservation of momentum and show that the law of conservation of momentum with a suitable example. Question can be asked in this way, and you will have to write like this only. First you will draw the figure, then after that you may go for writing. Let A and B are two bodies of masses m1 and m2 respectively. Clear? u1 and u2 are the initial velocities of two bodies. Okay, I will go for writing there. Do one thing. First you copy from there to here. From energy to up to this point. Copy this. Observe. Now you are going to write from here. See. First, law of conservation of momentum. You write this statement. After that, show that the law of conservation of momentum with a suitable example. Make the question yourself. Then after that, here only I will go for writing it. It is show that or prove that the law of conservation of momentum. See that. Now you have to start writing from here. A and B are two bodies of masses m1 and m2 respectively, moving in a straight line in the same direction. Next, u1 and u2 are their initial velocities. Here let us assume u1 is greater than u2. Then they collide with each other after some time. We have taken the time as t. When they collide with each other, their velocities changes. v1 and v2 are their final velocities. Got it? After writing this, you have to copy from here. So you have to draw this figure. Then after that, you write momentum of two bodies before collision and momentum of two bodies after collision. Here, before collision, initial momentum of A and initial momentum of B. After collision, final momentum of A, final momentum of B. Then you go for taking change in momentum, then rate of change of momentum of A, which is nothing but the force exerted by A on B. Next, rate of change of momentum of B, nothing but the force exerted by B on A. Then go for using Newton's third law of motion. To every action there is an equivalent opposite reaction. That is FAB is equal to minus FBA. Substitute, cancel. Then by interchanging the terms, finally you will get this one. It's very important. M1U1 plus M2U2 is equal to M1V1 plus M2V2. Here we can write, hence the law is derived or proved. Law is proved. The sum of momenta of two bodies before collision is equal to the sum of momenta of two bodies after collision, provided there is no external unbalanced forces acting on them. Got it? Okay, after copying this, we will go for solving some of the important problems. Dear students, you have to remember an important point, that is, as per our observation, when we go through previous year question papers, in most of the question papers, either derivation will be there regarding law of conservation of momentum, or one numerical problems will be there. Clear? And in that also we have particular. In that one problem is a bullet fired from the gun, And another problem is a girl jumps on the cart wheel. And third one, two hockey players, when they collide with each other, there also the law of conservation of momentum holds good. These are the three different types of problems which can be asked in the examination based on this law of conservation of momentum. Yes, please go for copy. Statement, question, and write up to the complete derivation. Dear students, it's an important numerical problem with respect to law of conservation of momentum. Please go through this statement. And before that, and you must remember this statement. The sum of momenta of two bodies, that is m1u1 plus m2u2, is equal to the sum of momenta of two bodies after collision, m1v1 plus m2v2. Here the first statement is like this. A bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? Dear students, here two objects are given. Can you tell them? Yes, one is bullet and second one is pistol, right? And two situations are there. What are those? One is the before firing and another one is after firing. These are the two situations. Just I'll go for drawing only to make you to understand this statement. See that here is the pistol and this is the trigger and here is the bullet. This is before firing. And again here I am taking, then a bullet is fired from the gun. This is after firing. That means the sum of momenta of bullet and pistol before firing is equal to the sum of momenta of bullet and pistol after firing, according to law of conservation of momentum. Is it not? Yes. I'll go for writing data first. What is that? See that. A bullet of mass 20 gram is given. Here with respect to bullet I'll write. With respect to bullet I'll write M1. What is M1? It is 20 gram. Is it in SI unit? No. So let us convert this into SI unit. 20 by 1000 kg. Then 0 get cancelled. It's equal to 1 by 50 kg. Clear? Then what about its initial velocity? Call it as u1. It is fired with a velocity 150 meter per second. So when it was at rest, its velocity was 0, right? 0 meter per second. Then when it is fired, after firing, it moves with a velocity v1 is equal to 150 meter per second. Hope that you have understood. Next, with respect to pistol, let us take its mass as m2. How much? From a pistol of mass 2 kg. Its initial velocity before firing, that is u2. This is 0 meter per second. Then you are going to find out what is the required velocity of the pistol. Obviously, when the bullet is fired from the pistol, then the pistol recoils. It comes backward. We have to find out that velocity. Recoil velocity of the pistol is v2. It is unknown. Question mark. Now let's move on to calculation. As we have two situations, one is before firing and another one is after firing, let's go for using the law of conservation of momentum. Here I write. According to the law of conservation of momentum, how do you write? Yes, it is m1u1 plus m2u2 is equal to m1v1 plus m2v2. Now let us go for substituting. See, here substitution is also very important. First you go for substituting M1, M2. Then it will be easier. M1 is the mass of the bullet. It is 1 by 50 kg. And M2, that is the mass of the pistol. This is 2 kg. Here I write 1 by 50 into M2. It is 2 into 1 by 50 into 2 into. Now you substitute U1 and U2. U1 is 0. U2 is also 0. That is, before firing, the bullet and pistol both were at rest. Hence, their initial velocity will be 0. Here I write 0, 0. V1 and V2. After firing, they move with different velocities, and bullet will move forward with some velocity, and the gun recoils. That means it comes backward with some velocity. It is V1 is 150 meter per second. It is the final velocity of the bullet, but final velocity of the pistol is unknown. Here I write V1 is 150. It is unknown V2. You may keep that as it is. Observe it. 50 ones are 53 are. Your 0 into anything is 0 plus 0. It's equal to 3 plus 2 V2. 0 plus 0. This is 0. It's equal to 3 plus 2 V2. Transfer 3 to the left hand side. Minus 3. It is equal to 2 V2. Then V2 is equal to minus 3 by 2 is nothing but minus 1.5. Did you understand? What is the recoil velocity of the pistol? You cannot say minus 1.5. It is just 1.5 meter per second. Then what does minus sign indicate? It indicates a recoiling velocity, negative velocity. Clear? Here I will write. Therefore, the recoil velocity of pistol is 1.5 meter per second. Understood? Yes. Please go for copying from here to there. Dear students, please go through this statement. This is also very nice and important one. The statement is like this. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart. Clear? With the frictionless wheels, the mass of the cart is 3 kg. What is the velocity as the cart start moving? Did you understand? See, here is a girl and this is the cart with frictionless wheels. She jumps on it. These are the two objects that are given. One is girl and another one is cart. When she jumps on it, we know that both will go together, right? Yes. Now, first let us write the data. Observe it. Or else you can do one thing. Pausing the video, you can go for copying the question. After that, just you can write it. Here are there are two objects. Which are those? One is girl and another one is cart. Here I will write. First, with respect to girl. A girl of mass 40 kg. What does 40 kg indicate? It is M1. 40 kg. With a horizontal velocity of 5 meter per second. This is the velocity with which she jumps. Then after, when she jumps on the cart and she will move with some other velocity. Then what does 5 meter per second indicate? It is initial velocity. Call it as U1. It is 5 meter per second. Then final velocity, it is unknown. Clear? Then next object is cart. On the stationary cart, that means the cart is at rest. When it is at rest, what will be its initial velocity? This will be 0, right? Any object with at rest, its velocity will be 0. The mass of the cart is 3 kg. I call it as M2. M2 equal to 3 kg. Then U2, this is 0 meter per second. And V2, it is unknown. Let's move on to calculation. Dear students, one thing you must remember, when the girl jumps on the cart which is at rest, then after jumping, and the girl will start moving with the cart. Hence, the final velocity of the girl as well as the cart both will be same. Here I'll write. When a girl jumps on stationary cart, then both move together. Can we write so? Yes. If it is so, then can we write V1 is equal to V2? Certain. You may call this as X. Here I write. According to law of conservation of momentum, yes, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, right? Let us go for substituting. As I said, first, which one should be substituted? M1 and M2. See that. M1 is 40, M2 is 3. Here I'll write 40 into plus 3 into 40 into plus 3 into. Next, U1 and U2. 5 and 0. It is 5, 0. V1 and V2. Both are unknown, but both are equal as they move together. We have taken them as X. Now this is 40 into 5. It is 200 plus 3 zeros are 0. 40 into X, 40X. 3 into X, 3X. Then this is 200 is equal to 43X. Then X is equal to 200 divided by 43, right? Now, let us go for dividing 200 by 43. 43, 4s are 4 3s are 12, carry 1. 4 4s are 16 plus 1 17. 10 minus 2, 8, 9 minus 7, 2, 1 minus 1, 0. You may put decimal, take 0, 280, 43. Whether it comes by 7? No. 6 are. 6 3s are 18, carry 1. 6 4s are 24, 25. 10 minus 8, 2. 7 minus 5, 2. It is, again take one more 0. 220. This will be 5 are. It is X equal to 4.65 meter per second. So this is the velocity with which cart starts moving, or the velocity with which girl start moving after jumping. Here we write the conclusion. Therefore, the girl's velocity after jumping is 4.65 meter per second. Here, hope that you might have written with me. If not, just go for copying. After this, we have one more important statement. It is related to hockey players. Copy this. Dear students, please go through this statement. It is: two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. One has a mass of 60 kg and was moving with a velocity 5 meter per second, while the other has a mass of 55 kg and was moving faster with a velocity 6 meter per second. Towards the first player, here is the first player and is second player. In which direction and with what velocity will they move after they become entangled? Assume that the frictional force acting between the feet of the two players and the ground is negligible. Hope that you have understood. Yeah, first you go for copying this whole statement, then you can start writing with me. Observe. Hope that you have written. Now, if you want to tell in which direction they will start moving after they become entangled, look here. To know that, you must find out the momentum of first player as well as the second player, right? And based on that, the impact produced by one having more momentum will exert more force on the other player, and towards that direction only they start moving after entangling, right? Okay, let us write that later. Now please write the data with me. It is, here they are given two objects, two players, and both are of opposite teams. I'll take the first and second player, means a player of first team and a player of second team, like this. First player. Then what is his mass? I call it as M1. His mass is 60 kg. 60 kg. And he is moving with a velocity U1. How much? Moving with a velocity 5 meter per second. Clear? Next. Why? The other has a mass of 55 kg. I'll take second player. Second player. Hope that you are writing with me. His mass is 55 kg. Then, and was moving faster with a velocity 6 meter per second. U1 is 6 meter per second. Then he is moving towards the first player. In which direction and what velocity will they move after they become entangled? When they become entangled, their final velocities will be same because they move together, right? You just keep that in mind. Here, final velocity of first player and final velocity of second player, both are unknown. Look here. First player is moving towards second player and second player is moving towards first player. But after entangling, in which direction they start moving? To find out that, first we should find out the momentum of both the players. Here I'll write momentum of first player, that is equal to, it is M1 U1. This is 60 into 5. It is equal to 65 is up. It is 300 kg meter per second. Right? Similarly, momentum of second player is equal to M2 U2. This is 55 kg into 6 meter per second. 6 5s are 33, 6 5s are 30, again 33, 330 kg meter per second. Then see that second player has more momentum. Here 330 kg meter per second is greater than 300 kg meter per second. Hence the impact produced by the second player will be more, right? Hence, as we know that 300, we know that the momentum of second player, it is 330 kg meter per second more than the first player. He will exert more force. Hence, towards which player they start moving? Towards first player only, right? Okay. Now, let's move on to finding another one. What is that? Velocity with which direction? With what velocity they move after they become entangled. Here I'll write the conclusion. Therefore, in which direction they move after they become entangled? They move from right to left, because in textbook they have given the figure that on the right side second player is there, left side first player is there. So after they become entangled, they move together, that is towards first player. Hope that you have copied up to here. Now we will go for finding the velocity with which they move together. So for that we have to use the law of conservation of momentum. What is the statement according to it? Here I'll write. According to the law of conservation of momentum. Conservation of momentum. How do you write? It is m1u1 plus m2u2 is equal to m1v1 plus m2v2. And one more important thing you must remember here, as they move together after entangling, therefore v1 is equal to v2. You may call this as x. First you substitute m1 and m2. 60 plus 55 into 60 into plus 55 into. Then u1 and u2, 5 and 6. v1 and v2, it is x. 65s are 300, this is 330. This is 60x plus 55x. 300 plus 330, it is 630 is equal to 60 plus 55, 150x. Then x is equal to 630 divided by 150. Just go for calculating this. Calculate. Hope that you have got 5 point some digits. But actually, one more thing you must remember. Second player is moving towards the first player. Hence, here velocity we have to take that as minus 6 meter per second. So then if it is minus, and this will be minus 330 and this will be just 30, then this is minus 30 by 150. Now I'll go for solving it. It is 5 2s are, then 3s are, 5 6 are, 6 by 23. Divide 6 by 23. 0 point, here 0. 2s are 46, it is 14. Take 1 0, then it is 6 are. 6 3s are 18, carry 1, 6 2s are 12, plus 1 13. So it is minus 0.26 meter per second. So we can write the conclusion as the velocity with which both the players move after entangling. How much? 0.26 meter per second. Clear? Yes. You may go for copying that. Hope that you have copied. Dear students, with this actually the chapter has been completed, but still we have to answer for the questions that are given in textbook. In between the lesson they have given some questions, we will answer them. Then after that we will also go for answering the exercise questions. Okay. Yeah. Before concluding, again I am reminding you, whatever we have covered today, please work out today itself without keeping anything pending. And particularly, you have to learn the statement of law of conservation of momentum. Second one, important derivation, and 3 important problems. You know that the problems are, one is bullet is fired from the gun. Second one is a girl jumps on a cart, and third one is 2 hockey players. Once I repeat, it is law of conservation of momentum statement, derivation, that is m1u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Next, numerical problems, bullet fired from the pistol. Second one is a girl jumps on the cart, and third one is 2 hockey players. Practice them. Tomorrow we will go for continuing this. So with this, let us stop the class. Thank you very much.